Very simple topic that we are starting for your course of physical pharmacy. The term dispersed system. How can we define the dispersed system? Very simple. The biphasic system in which one phase, that is the dispersed phase, is uniformly distributed into another phase that is known as uh, डिस्पर्जन मीडियम और कंटिन्यूस फेज, यानी दो फेज होते हैं जिनमें एक जो फेज है वो यूनिफॉर्मली डिस्ट्रीब्यूट होता है इन discrete unit या in small units के तौर पे. The dispersed phase as small units is distributed uniformly throughout a system, throughout a phase that is the continuous phase or the dispersion medium. Each phase can exist in either of these physical state, that is solid, liquid or gaseous state. And both of these phases can be exist in the form of solid, liquid or gaseous state. So the dispersed system majorly or broadly can be grouped as coarse dispersion, colloidal dispersion and true solutions. These are the main classification. This is the main classification for the dispersed system that is based on, as you can see here, on the particle size of dispersed phase. In coarse dispersion, the particle size is greater than 1 micron or micrometer. In colloidal dispersion, the particle size is ranging from 1 nanometer to 1 micrometer. And in true solution, the dispersion, as I have told you, that the dispersion is at molecular or ionic level. First of all, we will discuss about the coarse dispersions. The broadly we can classify it in pharmacy or as a pharmaceutical products. In pharmaceutical product, the coarse dispersions जो है वो they are broadly classified as suspensions and emulsions. So we'll discuss these suspensions and emulsions one by one in our this topic of coarse dispersion. As I have told you, the particle size of dispersed phase in these coarse dispersion is greater than 1 micron. What is the difference between suspension and emulsions? You all know well that what are the suspensions? Suspensions are dispersed system in which one substance as solid particle, that is dispersed phase, is uniformly distributed into a liquid medium. ठीक है? And in emulsions, the dispersed phase as that is actually the dispersed phase and the dispersion medium both are liquids. This is we can say that this is actually the dispersed phase system between two immiscible liquids that becomes miscible by incorporation of a third agent that is known as emulsifying agent. ठीक है, तो ये जो सस्पेंशन है ये एक सॉलिड और एक लिक्विड के दरमियान डिस्पर्जन है और इमल्जन जो है वो दो लिक्विड के दरमियान जो है डिस्पर्जन है, जिसमें एक जो डिस्पर्स फेज है एज स्मॉल ग्लोब्यूल्स or droplet that is uniformly distributed into another liquid, that is dispersion medium or continuous phase, and in presence of a third agent the system become that is known as emulsifying agent. ये सब हम चीजें बाद में बहुत डिटेल के साथ डिस्कस करेंगे. So that the system become emulsified in the presence of, यानी वन फेज नजर आता है, वो होता है टू फेज है लेकिन होमोजीनियस हो जाता है इन प्रेजेंस ऑफ अ थर्ड एजेंट दैट इज इमल्सिफाइंग एजेंट. ठीक है, तो हाउ कैन वी डिफाइन द बेसिक डिफरेंस? दिस वाज अ बेसिक डिफरेंस. नाउ द सस्पेंशन can be defined as a pharmaceutical suspension is a coarse dispersion in which insoluble solid particles are dispersed into a liquid medium. The particle have diameter of most part greater than 0.1 micrometer and some of particle are observed under a microscope to exhibit Brownian movement if the dispersion has a low viscosity. एग्जाम्पल्स द सस्पेंशन जो बनाए जाते हैं या जो डिस्पर्जन सेल सस्पेंशन बनाए जाते हैं, दे कैन बी यूज्ड ओरली एंड एज वेल एज topically or externally. Examples of oral suspension are oral antibiotic syrups, which normally contain 125 to 500 milligram per 5 ml of solid material. When formulated for use as pediatric drops, the concentration of suspended material is correspondingly greater. Antacids are also oral suspension that are radiopaque suspension, generally contain high concentration of dispersed phase. Externally applied suspension for topical use are lesion and under designed for dermatologic, cosmetic, and protective purpose. The concentration of dispersed phase may exceed 20%. Parenteral suspension contain from 0.5 to 30% of solid material or solid particle. Viscosity and particle size are significant factor because they affect the ease of injection and the availability of the drug in depot therapy. ठीक है जनाब. So these suspension can be prepared in all these three forms, that are oral, topical or external, and as parenteral. Now you can see here there are some desirable qualities or quality attributes of a suspension. We will discuss it one by one. An acceptable suspension possesses certain desirable qualities, including the following. The suspended material should not settle rapidly. So this is one of the major issue that is responsible for physical instability or failure of a suspension as pharmaceutical product. ये सबसे main reason है settling of the dispersed phase. This is the main reason that cause or that make the pharmaceutical suspension physically unstable. ठीक है. Formation, if the settling is too rapid, it forms hard cake. ठीक है. अगर बहुत ज्यादा तेजी से सेटलिंग होगी तो अल्टीमेटली व्हेन पार्टिकल्स गेट सेटल्ड दे फॉर्म hard cake that is not easy to redisperse, and the dose reproducibility is not possible. So dosing के लिए क्या चीज होनी चाहिए? That is the uniform distribution. यहाँ पे क्यों क्या है कि फार्मास्यूटिकल सस्पेंशन अगर हम बना रहे हैं तो डिस्पर्स फेज इज एक्चुअली मेडिसिनल एजेंट. जो डिस्पर्स फेज है इन द फॉर्म ऑफ पार्टिकल्स, दैट इज the medicinal agent. This medicinal agent or the drug that should be uniformly distributed throughout the medium in order to get dose to dose content uniformity. यानी क्या है कि uniformly distribute होगा तो when you will pour that suspension into the measuring spoon or the measuring device, you are getting the uniform dose. ठीक है. If the particles are uniformly distributed. If the hard cake is formed, that is not easy to redisperse, so there is no content uniformity, dose to dose content uniformity. So either in cases, चाहे वो oral suspension हो, parenteral suspension हो, वो topical suspension हो, there should be no settling of the particle, or there is no formation of hard cake. There should be no formation of a hard cake. The particles that do not settle to the bottom of the container must not form a hard cake, but should be readily dispersed into a uniform mixture when the container is shaken. The suspension must not be too viscous to pour freely from the orifice of the bottle or flow through the cylinder. Viscosity of the suspension must be considered. Depending on the nature of the type of the suspension or the type of the suspension, whether it is oral, topical, or parenteral, the viscosity must be considered. What viscosity a suspension must have, that if it is a oral suspension, that is easy to pour freely from the orifice of the bottle, or if it is parenteral, then it should be easily flow through a syringe needle. ठीक है. In case of an external lotion, the product must be fluid enough to spread easily of the affected area and yet must not be mobile that it runs off the surface to which it is applied. अगर externally apply कर रहे हैं तो तब भी the viscosity of the suspension must be considered, that it should कैसी होनी चाहिए कि यहाँ तो इतनी ज़्यादा उसकी viscosity ज़्यादा होना चाहिए कि it is not easy to apply over the skin, और ना ही इतनी उतना मोबाइल होना चाहिए कि यानी विस्कोसिटी उसकी इतनी कम नहीं होनी चाहिए कि व्हेन वी अप्लाई इट सो इट रन्स ऑफ द सरफेस टू व्हिच इट इज अप्लाइड. द लोशन मस्ट ड्राई क्विकली एंड प्रोवाइड एन इलास्टिक प्रोटेक्टिव फिल्म that will not rub off easily. ठीक है. It should retain while we are applying the external so while we are applying the suspension externally, so it should make a protective film over the skin, and it should dry quickly, and it must have an acceptable color and odor as well. The physical appearance must have a patient compliance in terms of its color and the odor. It is important that the characteristics of the dispersed phase be chosen when cared so that it produces a suspension having optimum physical, chemical, and pharmacological properties. This is the criteria for each pharmaceutical product. For every pharmaceutical product, either of it is suspension, it is syrup, it is capsule, whatever the type of dosage form is there, that all these products must have a physical, chemical, and pharmacological properties and optimum. Optimum means that is related with the effectiveness and stability of the product. ठीक है. Among these, the particle size distribution, these are physical and chemical properties. As I have told you that the physical pharmacy is the study of physicochemical characteristics in order to make an optimum pharmaceutical dosage form. So here you can see some of the physical properties that are particle size distribution, specific surface area, inhibition of crystal growth, and changes in polymorphic form of a special consideration. And the formulator must ensure that these and other properties do not change 1 to 3, that are physical, chemical, and pharmacological properties. Okay? So these two must not change sufficiently during storage and to adversely affect the performance of the suspension. Finally, it is desirable that the product contain readily obtainable ingredients that can be incorporated into the mixture with relative ease by the use of standard methods and equipment. Yani when we are, what does it mean? That when we are designing the formulation, we are making a composition to make this suspensions, either of the suspension, whether it is oral, topical, or parenteral. So the composition, that is the obtainable ingredient, हमें जो choose करने हैं वो हमें कौन से करने हैं, that when we formulate a suspension, that should be according the standard methods and equipment. For pharmaceutical purpose, physical stability of the suspension may be defined. अच्छा, now the जब अब ये बात आप खुद से की जाती है कि whenever you are formulating, you are designing a product, it should be stable. इफेक्टिवनेस के साथ उसका जो मेजर क्राइटेरिया है दैट इज द स्टेबिलिटी. तो जब हम स्टेबिलिटी की बात करते हैं तो इट शुड बी स्टेबल फिजिकली एंड केमिकली. सो देयर इज डिफरेंस बिटवीन द फिजिकल स्टेबिलिटी एंड केमिकल स्टेबिलिटी. Physical stability, that is any of the appearance, order, उसकी जो पार्टिकल साइज में डिस्ट्रीब्यूशन में कोई चेंज आ रही है, उसकी ऑर्डर में कोई चेंज आ रहा है, उसकी अपीयरेंस में कोई चेंज आ रहा है, दैट एक्चुअली रिलेटेड विद द effectiveness or dose to dose content uniformity, so we can say that the product is physically unstable. Okay, so like in this suspension, if the cake formation is there, hard cake formation is there, and we cannot reproduce the doses again and again, because it is not easily redispersible now. ठीक है, जब उसको शेक कर रहे हैं क्योंकि हार्ड केक बन गया तो वो रिडिस्पर्स नहीं हो रहा. ठीक है, तो क्या है कि हम डोज टू डोज जो एक रिप्रोड्यूसिबिलिटी है या डोज टू डोज जो कंटेंट यूनिफॉर्मिटी है वो प्रोड्यूस नहीं कर पा रहे. सो इट द प्रोडक्ट विल गोज टूवर्ड्स द फेलियर. Although the drug is stable, drug concentration is there, but due to formation of hard cake there is physical instability. What is the chemical instability of that is actually any kind of chemical interaction that will decompose the medicinal agent. ठीक है, कि जब फिजिकली हम बात कर रहे हैं, केमिकली हम बात कर रहे होते हैं, तो एक्चुअली केमिकल रिएक्शंस आर गोइंग इनसाइड. ठीक है, दैट आर डिकम्पोजिंग द एक्टिव इंग्रेडिएंट. फिजिकल अनस्टेबिलिटी क्या है कि प्रोडक्ट में डिकम्पोजिशन नहीं हो रही है. ठीक है, एक्टिव इंग्रेडिएंट डिकम्पोज नहीं हो रहा, डिग्रेड नहीं हो रहा, लेकिन जो है फिजिकली जो है वो अब प्रोडक्ट जो है इट नॉट इन सच कंडीशन दैट इट कैन प्रोड्यूस इट एफिकेसी. ठीक है जनाब. Suspension, ideally suspension should be thixotropic. This is the term that must be explained here. What does it mean? देखिए, हम बात कर रहे हैं अभी फिजिकल स्टेबिलिटी की, एंड द फॉर्मेशन ऑफ हार्ड केक is one of the reason that makes the suspension physically unstable. ठीक है, तो we should work on it. और हमें क्या करना है, हमें वो मॉडिफिकेशंस करनी है फॉर्मुलेशन में कि हार्ड केक या तो बन ही ना पाए. ठीक है, या अगर बन जाए वन इट इज फॉर्म्ड, तो इट शुड बी अ लूज सेडिमेंट. अब हम उसको केक नहीं कहेंगे बल्कि क्या कहेंगे, इट मस्ट बी अ लूज सेडिमेंट. ठीक है, दैट इज इजीली रीडिस्पर्सिबल ऑन शेकिंग. तो उसमें क्या है कि दिस इज एक्चुअली द थिक्सोट्रॉपिक एंड दिस इज नीडेड. ये क्यों जरूरी है, शेकिंग एंड ऑफ एंड रीडिस्पर्जन. ठीक है, क्यों जरूरी है, बिकॉज of to getting the uniform distribution of the medicament. शेकिंग होगी, रीडिस्पर्जन होगी, तो यूनिफॉर्म और होमोजीनियस डिस्पर्जन हो जाएगी थ्रू आउट द डिस्पर्जन मीडियम, एंड वी आर गेटिंग डोज टू डोज कंटेंट यूनिफॉर्मिटी. ठीक है, सो आइडियली दो तरह की कंडीशंस हैं कि व्हेन देयर इज द यूनिफॉर्म डिस्ट्रीब्यूशन of these solid particles or medicinal agent throughout the dispersion medium. One of these is that if the suspension is thixotropic. What is thixotropic? Thixotropic behavior is related with the time dependent changes in viscosity of a system when there is, or we can say under the influence of a applied stress. What is applied stress? That is force applied per unit area. ठीक है, time dependent changes in viscosity are of two types. ठीक है, one of these is that the system become viscous on standing. When the system is viscous on standing and thin readily on shaking, क्या चेंज आ रहा है कि जब वो रखी हुई है, बॉटल रखी हुई है, तो dispersion, the viscosity is in suspension, viscosity is related with the dispersion medium. तो thixotropic behavior क्या है? One of the kind of thixotropic behavior is that the system or the dispersion medium is viscous on shaking. यानी जब वो रखा हुआ है without the absence of any kind of applied stress or any kind of applied force. तो डिस्पर्जन मीडियम की विस्कोसिटी ज्यादा है, जेल है, इट इज लाइक अ जेल, ठीक है। एंड इट बिकम्स थिन, यानी इसकी विस्कोसिटी कम हो जाती है वो वाइल ऑन शेकिंग, यानी जब हम उस बॉटल को उठा के शेक करते हैं तो वो थिन हो जाता है, उसमें फ्लूइडिटी बढ़ जाती है एंड इट बिकम्स इजी टू पोर. So this is the ideal behavior because if it is viscous on standing, it is like a gel. The particle will remain suspended. जब वो जेल है तो क्या होगा, पार्टिकल की सेटलिंग नहीं होगी, क्योंकि केक कब बनेगा, जब पार्टिकल दे आर सेटलिंग रैपिडली, ठीक है। अब अगर जेल है, सिस्टम की विस्कोसिटी जो है वो बढ़ गई है अपॉन स्टैंडिंग, ठीक है। तो पार्टिकल जो है दे आर फेसिंग रेजिस्टेंट टू गेट सेटल्ड बिकॉज द जेल फॉर्मेशन इज देयर, तो वो हिंड्रेंस हो जाएगी, वो रेजिस्टेंस हो जाएगी उनकी सेटलिंग में, ठीक है। तो दे रिमेन सस्पेंडेड इन द डिस्पर्जन मीडियम, ठीक है, वो डिस्पर्जन मीडियम में कैसे रहेंगे, सस्पेंडेड रहेंगे, ठीक है। एंड बिकम थिन, और जैसे ही जब हमें जरूरत होगी हम बॉटल उठाएंगे, उसको शेक करेंगे तो इट बिकम्स थिन, वो लिक्विड बन जाएगा, ठीक है। और उससे हम बहुत इजीली जो है वी कैन रिप्रोड्यूस द डोज अगेन एंड अगेन by applying force, that we are applying force while we are shaking the bottle. It means that we are applying the force. When we are applying the force, the dispersion medium will lose its viscosity, it becomes thin, the particle will distributed uniformly throughout the medium, and we are getting the uniform dose after pouring that suspension into a measuring device. So this is an ideal situation that we can, if the suspension is showing thiotropic behavior that prevents the sedimentation of the particle during storage and allows easy withdrawal on shaking, ठीक है। Now what thing is responsible, or the set, what factors are there that can affect the settling of the dispersed phase in a pharmaceutical suspension, ठीक है। The settling of the particle follows the theory of sedimentation that is expressed in terms of Stokes law. You can see here, ठीक है। This is settling of the particle that follows the theory of sedimentation that based on Stokes law equation. Here you can see the Stokes equation is given as V is equals to d square rho s minus rho naught g 18 eta naught. So here are some factors that are shown in this Stokes equation. You can see here, and they are directly or indirectly related with the velocity of settling, that is also known as terminal velocity of dispersed phase, ठीक है। तो यहाँ पे आपको सबको ये इक्वेशन नजर आ रही है और इसमें आपको मुख्तलिफ फैक्टर्स नजर आ रहे हैं, मुख्तलिफ पैरामीटर्स नजर आ रहे हैं that are directly related with this terminal velocity or स्पीड ऑफ सेटलिंग और वेलोसिटी ऑफ सेटलिंग, कुछ भी कह लें आप उसको, उसे डायरेक्टली और इनडायरेक्टली रिलेटेड। इसमें से पहले आता है वो दैट इज द डी स्क्वायर, दैट डी इज द डायमीटर ऑफ पार्टिकल साइज, और वी कैन से द साइज ऑफ द पार्टिकल. What is the relationship between the settling of the particles with this particle size of the dispersed phase? That is the direct relationship. So you can see here, what does it mean that as smaller as the size will be, more velocity will be there. Particle size जितना small होगा, velocity sorry, particle size जितना small होगा, velocity मतलब जितना small होगा जितना कम होगा. हम अगर डायरेक्ट रिलेशनशिप बनाना चाह रहे हैं तो किस तरह कहेंगे कि जितना ज्यादा पार्टिकल साइज कम होगा उतनी ही ज्यादा वेलोसिटी भी कम होगी, जितना पार्टिकल साइज ज्यादा होगा उतनी ही वेलोसिटी भी, सेटलिंग भी या टर्मिनल वेलोसिटी भी उतनी ही तेजी से होगी, सेटलिंग ऑफ द पार्टिकल उतनी तेजी से होगी. तो दिस इज द डायरेक्ट रिलेशनशिप. ठीक है. इन अदर वर्ड वी कैन से स्मॉलर साइज. कम कम किस तरह कहेंगे कि स्मॉलर साइज ऑफ द पार्टिकल विल बी लेसर विल बी द सेटलिंग वेलोसिटी और द टर्मिनल वेलोसिटी. मोर or larger will be the particle size, more will be the velocity of the settling or terminal velocity of the dispersed particle. ठीक है. तो if we want to decrease the velocity, तो one of the क्या steps है और the one of the modification क्या है formulation में कि जितना कम हम particle size use करेंगे उतना ही particle जो है वो slowly settled होंगे. ठीक है. So you can observe in daily use commercial product very simple example is Panadol suspension. आप देख सकते हैं कि जो कैलपोल के नाम से आता है दिस अ काइंड ऑफ सस्पेंशन और उसमें आप देखेंगे द माइक्रोनाइज पार्टिकल्स आर यूज्ड. Another strategy is taken that is we will discuss later on. दोनों strategies आपको calpol suspension में मिलेंगी. One of the strategy is the micronization, that is the particle size reduction in order to reduce the velocity of settling or in order to prevent cake formation. ठीक है. The second parameter that is you can see here that is rho s minus rho naught, that is the viscosity difference between the dispersed particle and dispersion and dispersion medium. जितना ज़्यादा डेंसिटी डिफरेंस जो है दोनों का कम होगा उतना ही ज़्यादा सेटलिंग कम होगी. जितना ये डिफरेंस ज़्यादा होता जाएगा सेटलिंग उतनी ही तेजी से हो जाएगी. So what step should be taken? We cannot change the density of the dispersed particle, but we can alter the density of the dispersion medium or the liquid. So that is that can be done by incorporating some agents. You can see here. Okay. Another approach to decrease sedimentation is reduce difference in the densities of the dispersed particles and in the dispersion medium. But this approach is seldom possible because the density of the suspended solid particles is mostly greater than the liquid. So we can alter the density of the dispersion medium. So this can be possible in a limited condition. Then the next factor that is responsible for the settling or this terminal velocity eta naught is the viscosity of the dispersion medium that has an inverse relationship with the terminal velocity of dispersed phase. ठीक है. What does it mean? It means if we are increasing the viscosity of the dispersion medium, velocity will be reduced. Settling of the particle will be reduced. And we are decreasing. If we are increasing, the velocity will be decreased. If we are decreasing, the lesser will be the viscosity of the dispersion medium, more will be the velocity of the dispersed phase. ठीक है. तो अगर हम by incorporating various pharmaceutical agents that are actually viscosity increasing agent, we can increase the viscosity of the dispersion medium and reducing the velocity of the dispersed particle. In most pharmaceutical suspension contain dispersed particle in concentration of 5 to 10% or higher percentage. The particles exhibit hindered settling. According to Stokes' law, the rate of sedimentation of particles in suspension may be reduced by decreasing particle size, provided the particles are deflocculated. This term deflocculated we will discuss later on. The rate of sedimentation can also be decreased by increasing the viscosity of the dispersion medium, for example, by addition of suspending agents. or thickening agent. However, there is an optimum level up to which the viscosity of the dispersion medium can be increased, since too much increase in viscosity may hinder the uniform dispersion of suspended particles after they have settled, would also pose problem for easy flow of suspension from container. So we can apply these approaches to some extent. Now another factor, that is the Brownian movement, an important role plays an important role in settling of the particles. The Brownian movement for dispersed particles. For particles having a diameter of about 2 to 5 micrometer, depending on the density of the particles and the density of the viscosity of the suspending medium, Brownian movement counteracts sedimentation to a measurable extent at room temperature by keeping the dispersed material in random motion. So Brownian movement of the system plays an important role in settling of the particle. इसको मैं यहीं तक रखती हूँ इस टॉपिक को इंशाल्लाह जो इस टॉपिक को कंटिन्यू करूंगी अपनी फिजिकल क्लासेस में. Now I'm taking the attendance, so get ready for it. Asma. Okay.